Network security devices are a staple of any secure environment. To find out more, stay tuned.
You're watching IT Pro TV.
Hello, everyone, and I'm glad you could make it back for more GSEC because we're talking about network security devices. That's actually a lot of things to say right there, and we're going to start on probably something you think of anytime you go. Network, I need to make secure, and that's firewalls. Daniel, I need a firewall for everything, right? A firewall for my firewall to put a firewall for my car.
If you ain't firewalling it, you ain't doing it right. That's exactly
Nailed
correct. Yes. So we have host-based firewalls. We also have network firewalls. Today we are talking about networking and network security devices. A firewall, as Justin said, is probably the first thing that might pop to your head on, hey, let's secure this thing up a little bit. And it's a fairly simple process, right? I have a device. It has network traffic coming in and lets network traffic go out, but only depending on a set of rules that are built into the device itself, right? So it is going to be a point in your network that is kind of acts as a filter, okay? So with firewalls, we just have to set those up correctly for our environment. And of course, I would love to give you a full-on firewall, dissertation on how to properly set up your firewall. A, that's just too out of scope for this exam, and B, that would be its own series. It would take quite some time for that to happen. But what we can do is just understand the basics of firewalls within inside the Linux operating system and the Windows operating system. So let's start with Linux. Let's jump here into my lovely little laptop here, running my Kali Linux machine. And we have another device as well, which is our lovely prod one. You see it's looking for my password, but I'm playing around with IP tables because IP tables is what we are going to use for our firewall today. So just for proof of concept, I can ping this device. So 10.10.10.130, I believe it is. Yay, I'm pinging. I'm seeing it all come back. It's a wonderful thing. Also, if I go to a web browser, you'll notice up there, 10.10.10.130, I'm getting the splash page for Apache 2. I also have DVWA installed, so if I go to that, you'll see I have full access into the system. But firewalls are all about control, right? And secure control access of different things. I could shut off access to ICMP, and that would stop me from being able to ping, but I'd still be able to grab the website. Let me show you what I mean. Jump over to prod one here, and first I will just show you IP tables. The actual rules I have in place. I can't type and talk at the same time. There we go, especially when I'm typing in my password. It's like, brain, no, talk, words, password, wrong. But there you go. We've got an input chain, we got a forward chain, we got an output chain, and you'll notice that the default policy for each one of these is accept, right? So basically you have accept, I think it's reject, if I'm remembering correctly, and drop, or something like that. I think I always get reject wrong. We can check IP tables man page for the actual thing. I typically use drop because I just want you to, if I'm not accepting it, I'm going to drop it. Sometimes you want to do something different, but that's typically where I live. And for our intents and purposes, that should be fine. So I got nothing going on right here. That's why I'm able to ping, and that's why I'm able to get to that website. But if I start creating rules for it, so IP tables -I into the input chain. Again, we got the different chains here. Input, data coming in, right? Forward, do I need to send it to something else? Or output, is it going out, basically egressing from the device, right? Here I'm going to mess with the input chain because ping packets come in. And if I don't let them come in, then it won't reply. It'll just act like it doesn't exist. So input, and then I'm going to say -P for the protocol, which is ICMP. There we go. And then -J, which tells it to, basically this is where we're going to tell it what to do, accept, reject, or drop. I will do drop because that's what I want to do, right? Put that in. I don't get any errors. This lets me know I should be okay. I can definitely run iptables -L, and now I can see that drop ICMP from anywhere. So now what I'm basically saying is that no machine has ping access to this machine. It doesn't matter where it's from, doesn't matter what it's doing, right? If you're trying to ping me, not going to allow it. So let's go to Kali, get back in our terminal there, and we will clear the screen and run that ping again. And now you see nothing is happening. I'm getting no replies or anything like that. If I Control C this, I get 100% packet loss, just as we expect.
And this is one of those things, I went ahead and helped you out a little bit.
Yes,
those connection responses, accept, drop, or reject. Reject would send back an error. I tend to favor
the drop.
I'm big on things like that. Like, I'm not going to tell you jack.
Right.
Because if I give you a reject, then you know something's there.
Yeah. Let's change it and see because we're probably going to get a reply, but it's going to be like host unreachable or something like that. So let's mess with it. We'll flush that IP table out. So sudo IP tables dash, or I think it's just dash flush is what I usually use. There we go. We'll recreate this, but this time we will use, and it is reject, correct?
Yep.
All right, look at me. I'm getting it right. Excellent. One more time. Run that ping. And now you're seeing destination port unreachable. So with a reject, you might get a little more information, but that's one of the reasons I typically go with drop is because you get nothing back. You have no idea whether the host is live or not, or if it's actively rejecting, right? But like I said, this is only for ICMP. If we ran an Nmap scan on this, I'll do an ST, and then just to make it fast. You're like, what is going on? Don't worry about all the switches here. I'm just making, I'm telling it not to do certain things so that it's quick. 10, 10, 10, 130, and then there we go. And you see it was very fast, but I can see that there are ports open, right? So how do I stop that kind of thing? Well, I can say, you know what? I just want to block TCP traffic. Now, I could do like what I just did and block broad brush TCP traffic from everyone. That doesn't make a whole lot of sense. Maybe I have an area that shouldn't come in, or maybe I create a rule that says only this device can access these things. With that kind of stuff, you're just going to be working with source and destination stuff. So let's do that. Let's create a rule that will block that machine. Let's block Kali. So I'll clear out here, and we will sudo IP tables -i for the input chain, and we will do -p TCP. So this will block all TCP. I can do a dash. What's it? Do I need a -s? Sometimes I feel like I do. Let me try that. I think I do need a -s for source. And then we will say 10, 10, 10, 133, I think is my IP address. We'll see if I get it right. -j drop. There we go. It should be in there. Of course, sudo IP tables -l. And it's taking a second to build. I don't know why. It did this to me before. It was like kind of slow when I was adding rules. Anyway, there it goes.
That's weird. Why would it?
I don't know.
Maybe it's using a weird, like a local database or something. And it's like,
Couldn't tell you.
I don't know. Oh, well.
But here you go. There's that drop from that source. So to get it right, -s for source. And bada bing. Now I rerun my Nmap scan. You notice that the last time it ran in like 0.11 seconds. And now it's not running at all, or it's not giving us any kind of reply because it's not able to contact that. We can see that again and kind of worked out by, oh, I want to go to that login page or just go back to that splash page, right? Just give me some, it does still work as it's caching it. Let me reload it. Oh yeah, there you go. See that just going back and forth and back and forth? It's not giving me nothing. Ultimately, that will time out and give me an error on the page. So there you go. There you go. Connection is timed out. This is probably done too. Oh, it's still going. Man, this has got a minute remaining. Anyway, obviously not working as it once did. The firewall is working as expected. And again, get really familiar with your firewall's rules when it comes to Linux, because they can be a little complex. Justin said you were playing around with Universal Firewall and found it to be quite agreeable.
Yeah, I remember it was one of those things where when I first did it, I was like, this is complicated.
Yeah.
And then you come back to it after you learn some more things, you go,
Yeah.
this is nice.
Yeah.
This is nice. And it's something that I'm trying to get more of the habit of, like when I deploy web apps or whatever, to go ahead and lock down anything else. Just to get in the habit of saying, all right, security is paramount. when I'm doing these deploys, because as you saw with the Nmap scan, there's other services running, and I don't, if I can help it, I don't want other individuals like seeing those services, right? If I only want to administer my web app machines from my house, then I'm only going to allow SSH from my house,
Correct.
not from anywhere, like the McDonald's coffee shop, or McDonald's coffee shop. You know what I'm talking about. Now,
That McCafe.
that McCafe gets you every time. It's high quality, high
good
quality.
stuff, good stuff.
Now, this is host based, right?
Right. Yeah. This is host, but it is a network firewall. So if I wanted to build an appliance,
Gotcha.
right?
Then
So technically, it's not a host, but you can use it as a networked system. You
so I could set it between my network and all
you
my other hosts.
multi-home the device,
Okay.
and it acts as an appliance. It's a good thing to bring up. Typically, firewalls are appliances, a piece of physical equipment. Stick in a rack, plug stuff into it, and that's how it works. This is just more convenient than that because I don't have a firewall running around. This is a more convenient one. Again, with Windows, you have that as well. I don't know if you can do the multi-home stuff with it, but it does have a firewall that will allow you to do this. Set up rules, tell it what to look for based on application or source and destination, that kind of stuff. Both really good, and we've seen that before. A couple of things, other thing I want to jump into is the fact that these firewalls are also stateful. What we've seen so far is just access control lists, ACLs, right? Which are great, they're fine, they work fine. But if you need a little more oomph to your firewall, right? A little more in-depth look at what's going on, you can use a stateful firewall, which both IP tables, UFW, and the Windows firewall are stateful firewalls. And of course, if you buy an appliance, the money you spend on those things, it's almost guaranteed that it is also a stateful firewall. So what does that mean? What that means is it actually tracks the state of the connections. So if my computer wanted to make a connection to Justin's computer and I had to go through a firewall to do it, it would say, well, what kind of connections are allowed? Am I allowing connections from the outside that originate outside of our network into our network? And if so, where is that allowed to? So I'd have to create a connection state that says, if I have a new state from Daniel's computer to Justin's, then I'll allow that. Anything else, I'm not going to allow, right? So it's looking at those connection states. You also have things like established connections, right? So if Justin's computer reached out and made a connection to a website and the website was replying to it, it considers that to be an established connection. So take a look at that. Again, all that stuff should be inside of the documentation of your specific firewall, whatever you're using. So it's really good. Within IP tables, it's contract, -CONNTRACK, if I'm not mistaken. At least that's what it used to be. And that will allow you to track those connection states. And it'll give you the parameters for that inside the man page. With Windows, I think it just does it by default. It's just checking that stuff. I don't know how deep dive you can get inside of that stuff. But if you had an appliance, you have mostly full control, if not full control, depending on what you had bought. But there you go. Different types of firewalls. You got ACL-based firewalls, just rule-based firewall, and you also have stateful firewalls to help you out with that. Now, Justin, I don't know. Have you heard the debate between? Hey, are you familiar with next generation firewalls?
No, that sounds like a marketer came up with it. I was like,
So
I turned it on. I was like,
This is completely not scripted, ladies and gentlemen. I am legitimately asking him a question in the middle of our show. How about a universal threat management?
nah.
All right. If you've heard of those things, they're basically the same thing. But they are super, super powerful. So this is taking your firewall and it's like, are you about to get swole? Right? And giving it the performance enhancers. Yeah, they can do a lot more. Not only do they do what we've already talked about, they do a ton of other things as well. I made a litany or a list, a myriad of different things that it can do. It can work with encryption, which is huge. I can load encryption keys into the firewall, and then it can inspect encrypted traffic. So that's really helpful, especially if you're trying to keep the thing secure. One of the great ways of going in and out of a system without detection was to tunnel through something like SSH or SSL. Use some encryption to mask that conversation so that the firewall was unaware of what's going on. But if I'm loading up encryption keys, I'm saying, hey, you only talk with this, or if it can do like a PKI kind of thing, wonderful. It can look and inspect all that traffic, verify there's no malfeasance, and then deal with it accordingly. It also does intrusion detection and intrusion prevention, right? Most of these do. Like if you're looking for a quality UTM or next-gen firewall appliance, these are the things you should probably be looking for as part of the suite of things that they do. Also does antivirus, anti-malware, built in. Has signatures, anomaly, looks at the stuff, checks it out. Oh, I know this signature. This is a virus. Nope. And it puts the kibosh on it, right? It'll do sandboxing, which is actually really cool. You'll spin up a VM, and it will, if it suspects traffic or like an attachment, it will send it to the VM, execute the thing inside the virtual, and see how it reacts. If everything goes fine, then it sends it on its way. If not, it goes, this is a problem. Not going to do that. Yeah. We're, like I said, this thing, bad to the bone.
Daniel, all I'm hearing is money. I'm just hearing, I'm like, man, that is a lot of change.
Yeah, we should probably get to that a little bit. You start looking at these things, they're not the cheapest things in the world, but if you're running an enterprise level corporation or organization,
so
it's money well spent.
I'm pretty sure something like this was in place at a school system that I worked at a very centralized look, because it filtering, it would check things, it would remove traffic. I mean, they had it on lock.
They are nice.
So from an end user perspective, as someone who
horrible.
talked, it was. I was like, come on, I just need to send a zip file, man.
No.
Yeah,
Stop it.
I know. It was rough. And speaking of, you talked about they can do intrusion detection, but there's some things that just do intrusion detection and prevention by themselves, right?
Yeah, there are. You can just purchase an appliance for NIDS and NIPS, as we like to call them, which is Network Intrusion Detection Systems and Network Intrusion Prevention Systems. That is fun to try to get out of your head. So it would be just a standalone appliance that could do those things. Now, there are pros and cons to going with an all-in-one solution like a UTM, or with, you know what, I'm going to buy a firewall and I'm going to buy an NIDS and an NIPS, and they're going to be their own appliances, and they'll talk to each other accordingly. But typically it's performance, right? Can the UTM really keep up with a dedicated firewall and a dedicated NIDS NIPS? Nowadays, it's probably. I mean, they have multi-gigabit bandwidth now, and the processors are getting sick. So, and I mean that in a good way.
I mean, that's sick.
Yeah,
right.
that's,
Tone's important there.
Super.
Yeah, hardware has come a long way
time.
as far as those, because it used to be all-in-one machines. People were like, nah, you can't.
Right.
It's
Can't
gonna
keep up.
Can't keep up, but that's not true.
Yeah, it's probably not true anymore. A couple of things we do need to know about NIPS and NIDS, though, is that how they do what they do. And ultimately, it usually boils down to two different things. Either does one, does the other, or does both. If it's any good, it does both, which is signature-based, right? It has, here's a list of things that are bad, don't let that happen. And then it's anomalies, where it actually has some kind of like AI machine learning, where it's looking at baselines and then figuring out what is odd activity. And when it detects odd activity, it might alert somebody. If it detects activity that's really odd, it might prevent some things, and it's just like by default because you've configured it that way. But it will be learning how your environment is normally looking, and then when it sees anomalies, it'll shut it down and give an alert. So be aware of those different types of systems when it comes to network intrusion detections and prevention systems.
Well, Daniel, thank you so much. I'm getting a little more used to using these firewall systems, and
It's not too bad.
you definitely need to dig in, because it's pretty low-hanging fruit once you get used to it. So definitely make use of those. Now, I don't have that money for those next generation firewalls or UTMs, and haven't had a necessary reason to deploy
Well, you don't
a
have
network.
an enterprise level network either.
Exactly.
There's
exactly.
that.
But if you do, you should definitely check them out. But for this episode, we're going to go ahead and call it done. So signing out for IT Pro TV, I've been your host, Justin Dennison,
I'm Daniel Lowry.
and we'll see you next time.
Thank you for watching IT Pro TV.